Clarifying and simplifying trigonometric identities. What this boils down to is some of those tricks that we were working with the equations last week where whereas when we had a tangent problem that I told you guys to switch to sine over cosine, like things like that. What I want to do here today is just kind of go over these. What happens here is we get what are called trigonometric identities. These trig identities are basically cosecant is 1 over sine, secant is 1 over cosine, cotangent is 1 over tangent, right? And you can flip them around a little bit. You can also say that sine is 1 over cosecant, cosine is 1 over secant, and tangent is 1 over cotangent. This is the unit that they use lots of thetas and x's and all that after all of the trig functions. I rarely, if ever, write down x or theta. If you guys forget or you guys don't write it, it's not a big deal. We're not actually solving like equations in this stuff. We're going to be simplifying a lot of stuff by using. It's kind of like a proof, if you will. It's an algebraic proof that's not two-column. You're going to use identities and rewrites and substitutions to solve these things through. Okay. Tangent, obviously, sine over cosine. Cotangent, cosine over sine. We knew that. We did. What's going to be new are your Pythagorean identities. Usually, I think some of you guys told me that this wasn't on the ACT this time around. Was it? Did you see that, Bill? Usually there's a trig identity like the sine squared plus cosine squared on there. What this says is that sine squared plus cosine squared is 1. Which means I could move and manipulate this equation around to have, say that sine squared is 1 minus cosine squared. You agree? What did I do? I just switched them around. It's exactly. And then also I can say that cosine squared is 1 minus sine squared. All I'm doing is move this up around. I can do the same thing with secant, or excuse me, the tangent. I could say that tangent squared is secant squared minus 1. And cotangent squared is cosecant squared minus 1. If you wanted to be fancy and write in terms of ones, you could. You know, 1 is secant squared minus tangent squared. That doesn't show up very often, nor does 1 equaling cosecant squared minus cotangent squared. Usually, these are the properties that you see. What these things are going to let you guys do is we're going to be able to go through a bunch of examples and show you how you can rewrite them in terms of other trig identities. That's all this does. Which, when we get to some more of the more complex equations, by rewriting them in terms of sines and cosines, it becomes a lot easier to solve. Okay? I'm not going to lie, you're going to hate this. It's very typical that people hate this the first day or so, and then they go, oh, that's how you do it. About halfway through the second day of doing this, okay? Unless what? Yeah, she'll have it like 30 seconds, and then she's gonna get really excited. She's start
and then
doing
she's gonna
this.
start getting angry because you didn't give us the homework.
Exactly. So let me show you an example. Whoop, I did 2 of those. I don't know if you can see that very well.
Oh, horrible. Gosh.
Sine of b divided by the tangent of b equals cos b. Here's how. It is kind of soon on that one, now that I think about it. Here's what we're going to do. what I want to do here is simplify this. You use a lot of division and multiplying by reciprocals with these things. A lot. What I'm going to show you is kind of like a systematic way of setting something like this up to simplify. Of why did this equal cosine of b? Here's what happens. Sine of b doesn't change. It's in the numerator. What I can do, though, is this, times 1 over that. All I did is split apart the fraction. Is that legal?
Yes.
No.
Yeah. Today it is.
Conversion.
Okay. What is 1 over tangent? Cotangent. So this is the same as saying sine times cotangent. You guys okay with that? Cotangent's what over what?
1 over 10.
In terms of sines and cosines.
Cosine over sine.
So this equals then, as you simplify through, sine times cosine over sine, and what happens?
You simplify this.
And Destiny just got it of why that works.
Sweet.
Wait, what's sine?
Wait a minute.
But why is cotangent?
Oh, it's equals,
That's
okay.
the rule. Tangent, sine over cosine,
Cosine B.
and if cosine, yeah. And if cotangent is the inverse of tangent, you just flip the fraction. And this is a good point, Hannah, of why I forget letters, the theta or the x. So why is sine of b divided by the tangent of b equal to cos b?
Because of that.
Because of that. Yes, sir.
Couldn't you also go like the opposites over hypotenuses and adjacents and all that?
You can if you want. It's just a lot messier. Okay? It's a lot messier. I'll show you another one.
This music remember.
We're going to simplify these two. You guys have in front of you your conversions, your reciprocals. You're going to have to know these off the top of your head. When I'm looking at cotangent and secant, a lot of times one of the first things you want to do is rewrite inverses in terms of sines and cosines. That's always your best bet to start with. So cotangent is what over what?
1 over tangent.
It's 1 over tangent, but in other words, it's also,
Cosine over sine.
go right to that.
Oh.
It's cosine over sine. Secant is the inverse of what? So what happens?
The cosine drop.
Cosines drop, you get 1 over sine, which is
Cosecant.
cosecant.
Okay.
You're using fractions, and you're just simplifying. It's a puzzle. Okay? Sine of x times the quantity 1 plus cotangent squared. Well, we did this one a second ago. 1 plus, well, we wrote down the 1 plus cotangent. 1 plus cotangent squared is cosecant squared, I believe.
Yes.
Okay?
How do we? Because it's on the thing.
It's on the thing. You're going to have to know your Pythagorean identities. The inverses of sines, cosines, and tangents, those are pretty simple to remember. It's when you get down into the Pythagoreans that you have to spend a little bit more time on. So 1 plus cotangent squared is cosecant squared.
Where's that?
It's on.
Oh, cosecant squared.
Okay? You guys okay on that?
Yeah.
Cosecant squared is the inverse of what trig function?
1 over sine squared.
So this is the same as saying sine times 1 over sine squared.
So the answer is 1.
Oh, wouldn't it be sine?
Yeah.
So sine,
Sine.
one of these drops out, right?
Yeah. And so then 1 over sine is cosecant. Cosecant.
Where'd the x go?
It's just me. I usually don't write the x values down because I don't want you guys to get mudded up with too many letters. That's all. You don't have to write it. Your book does. I think most other people do. I don't because I think it just looks messy. That's all. It's just my own It's just my own personal opinion. Okay. I'm not going to count against you if you forget it. because it's not that big of a deal. Because we're not trying to find the value, we're just simplifying things through. Okay? There's a lot of this. There's a lot of this. This is just starting.
Oh, whoa, okay.
We're not going to do negative any of
That's
this.
weird. Awesome. Alright, well, we've been doing it for like 5 minutes.
Yeah, like I said, it's going to take time. It's going to take time.
Wait a second.
A lot of times when you're simplifying, or eventually we start talking about what's called verifying, you, like I said earlier, try to switch things into terms of sines and cosines right off the bat before you jump into the Pythagorean identities. Pythagorean identities are usually a little bit more helpful if there's like a +1, if there's a 1 involved, because you have, in all the identities, there's always a 1. If you don't see that, try to go sines and cosines. So if I rewrite this in terms of sines and cosines, secant squared is the inverse of what? Cosine. So can I say that this is 1 over cosine squared? Minus, or better yet, go right to sines and cosines. Oh, careful.
Does it matter where you throw this? Oh, you need to throw it in both spots?
Yep.
Squared? Okay. Wait, what happened right there?
Tangent sine over cosine. So tangent squared, sine squared over
Oh,
cosine
okay, I
squared.
got it.
So now, notice we have a common denominator.
Yeah.
When you have a common denominator, you just put them together. So you have 1 minus sine squared over cosine squared.
And then that's
And then that's what?
cosine.
1 minus sine squared. That's telling you, hey, there's an identity because there's a 1 and a minus something squared, which should be an identity, which is
Cosine
So
squared.
what's cosine squared over cosine squared?
Equals 1.
Uno.
Oh, this is terrible.
You get 1.
So confused.
It takes time, Izzy. I told you that. It's been 6.5 minutes.
I don't have time for this.
Ain't nobody. How did the 1 minus sine squared equal?
Turning this over.
It's one of the Pythagorean identities is sine squared plus cosine squared is 1. All right. All we're doing is we're rewriting a bunch of terms in terms of other things.
So the answer is 1.
The answer is 1. It simplifies out to being 1. Nobody said this.
And like, give us the answer, then we have to figure out how we got the answer, or we have to just find.
That's the different part here, Michael. This is the part where it says verify. The simplified problems is you don't know if you're done yet. The verify is kind of like a true on proof. You're trying to show that it equals 1. Well, how does it equal 1? So at least they're telling you what your answer should be with the verifies. Okay? So here we have tangent times cosecant times cosine. Verify that it equals 1. So your left-hand side, we've got tangents, cosecants, and cosines. What do you think you should do right off the bat?
Make the tangent.
Make tangent sine over cosine.
Yep.
And then make cosecant 1 over sine.
Good. Right off the bat, since there are no +1s or anything like that mixed in here, I'm going to go ahead and rewrite everything in terms of sines and cosines. It tends to be a little bit easier. So we have sine over cosine times 1 over sine times cosine over 1.
Oh,
What
Oh, he
happens?
just
divided.
You get 1.
Will they all be that easy?
No.
I like that one.
Okay. That's what this looks like. Yes, ma'am.
So, is tangent the only one that's like sine over cosine and cosine's not tangent cosine or anything?
No. No. Okay. All right. All right, let's verify this.
Okay.
Cotangent squared over cosecant is going to be equal to cosecant minus sine. Here's a little trick. Notice how it's going from a singular fraction to two terms.
Yeah.
That means that your singular fraction had to be broken into two parts.
So you see right coming up.
Right, so what's happening here is you're going to try to rewrite, when you see something like that and you don't have two terms in your numerator or two terms in your denominator, you're going to want to create that. What do you see?
Does cotangent squared, would that turn into cosine squared and sine squared? Or-
It would, but what I want to do here is, in this case, since I'm breaking it into a fraction to subtraction, that holds some traction.
Okay, keep it going.
I can't get no satisfaction.
Okay. I see. Keep going.
I got it. I'm a man of action. I like your reaction. I own this distraction. I got that. Anyway.
We hit that whip next time, don't we?
Right. What's that?
As a dance. I feel like if you were dancing during that, it'd make it 10 times better. Maybe next year. There we go.
Cotangent squared is, can I rewrite cotangent squared as two terms? I could do that, but think of it in terms of something minus something or something plus something.
Cosine squared minus sine.
Cosine, yes.
Cotangent,
Cosine squared minus cosecant, whatever.
What?
cotangent squared, Pythagorean identity, cotangent squared is cosecant squared minus 1. Notice what happened here is I took the numerator and wrote it in terms of two parts with the subtraction. Now, think about rules of common denominators. You could rewrite this as two separate parts.
Oh, yeah, you can do that.
Oh, and then you inverse that one.
And then
Why?
Why is there cosine squared over the cosine?
Think about common denominators. Think about when you have common denominators. In order to do this, if you had it's the same basic idea. It's the same basic idea to do that. It's working in reverse of the common denominator. If you have the common denominator, you can put it all underneath the same term.
Wait. Sorry, I had like a revelation. Because that's a cosecant and then 1 over cosecant sine.
Correct. What's happening here is I'm working backwards from the common denominator.
That's still the first part, like the cosine
Yeah.
squared is, okay.
Yeah.
The equal sign is messing me up.
Yeah.
There's an equal sign for the cosine.
Oh, yeah, I'm getting, here, how about this?
Okay, yeah.
How about that? How about I put an arrow? Okay, how about I just put an arrow? All right, sorry. I see what she was saying, she thought that this equaled this right off the bat. I'm working my way to that.
So we have.
Because the first time we had to verify, I kept thinking the equals one part.
So cosecant squared over cosecant is how much?
Cosecant.
Cosecant. 1 over cosecant is,
Sine.
and I verified it.
So what would you put for the answer?
You showed your work.
So you-
That's the answer. You're showing me that it works. Okay?
So if you
Verifying.
get both sides equal to each other, it's done.
Right.
So what
So
if
you
it
don't even
not?
work with the rice.
What if it doesn't work?
It should. You should get the same answer. Okay. Sorry, go
Did you
ahead.
work like backwards and then try to show the right side was the left side or just the right?
Traditionally, it's always left to right.
Okay.
Okay, it is very rare. It's very rare that you go right to left. It's usually more difficult to go right to left, to be honest with you. This one isn't that bad because you can do common denominator stuff here to make it work. But it's traditionally, you're going to go 98.9% of the time left to right. Yes, sir?
So basically, you're just like proving the answer?
Yes.
Okay.
That's why I say it's like a trigonometric proof. Sorry.
So I'm confused how you got from cosecant squared over cosecant minus 1 over cosecant to cosecant minus sine.
Well, what's cosecant squared over cosecant?
Cosecant.
What's 1 over cosecant?
Oh, okay.
There we go. Okay. Let's try another one. We're going to verify this one. We'll start with sine of x. We want sine of x over 1 minus cosine. We want it to show that it equals this when we're done. Okay? We want to show that sine over 1 minus cosine is going to equal the 1 plus cosine over sine. Yes, ma'am?
Okay, like after this problem, if they were to like give us something like what we have on the sheet, and you don't actually have to like do any work, you just like never mind, you use it, I'm sorry how I explain it, you just write over the limit like Pythagorean.
That's rare. You'll have to do something with a lot. You'll have to at least simplify. It's just a matter of crossing something out over a fraction. It's like dimensional analysis, dropping your units. Is really what this winds up being. Another way of simplifying things through is to again multiply by conjugates.
Oh, I got
What's
it.
the conjugate?
So is this simplified?
With the eyes.
So these are just.
Same idea. If your denominator, back when we dealt with i's, if your denominator and you had to simplify this, what would you multiply top and bottom?
2 plus I.
2 plus I, because what you were doing is you were creating a perfect square in the denominator. By multiplying top and bottom by a conjugate, you're not changing the value, oops, because you're multiplying by a factor of?
What?
Correct. So what I'm going to do here is the same idea.
1 plus cosine?
Correct. So my top and bottom will multiply by 1 plus cosine. Okay? Everybody all right on that?
Yeah.
Now, if I look at it, 1 minus cosine times 1 plus cosine, that's going to wind up being a difference of squares. That'd be 1 squared minus cosine squared. You okay with that?
Sure. So this 1 minus cosine.
Wait, I thought that would be like killing a puppy.
We're not killing a puppy.
It
Because
feels like it.
if you foil this out, you get 1 plus cosine minus cosine squared. Plus cosine minus cosine drop, you get 1 minus cosine. That's what happens. Okay? So your denominator here becomes 1 minus cosine squared. Your numerator is just sine times the quantity 1 plus cosine. Bless you.
Equals sine.
Is sine squared?
Denominator is what, Michael?
Sine squared.
Sine squared, good. So your denominator becomes sine squared. What? Sine drops out. And now,
Bam, they're equal.
and kabam, they're equal.
Let's go. Let's eat. Let's eat.
Okay? Like I said, you guys are going to get very, very angry. And that's okay. I can deal with it.
As long as you still wrap to us out.
Yeah. So I got the skills that pay the bills.
It's spitting.
Here you go. Simplify.
Wait, what do you do with the other side?
Okay, we're just simplifying this one.
Wait,
Ben, that one we're verifying. We wanted to show that it
that's-
equal.
You're not solving, you're
Nope.
just showing it. Got it.
Simplify. So we have secant plus 1 times secant minus 1, all over tangent. Doesn't that numerator work out to be very good. Your numerator, if you FOIL that out, don't you get secant squared minus 1?
Yeah.
Okay. What's secant squared minus 1?
Tangent squared.
Wait, why?
Because it said so.
Where?
That's not
Oh.
And what do you get?
Tangent.
There's your answer.
What?
You watch a movie.
Ready? Go.
Jared, what are you making, hero?
You're taking. No.
Verify.
You finish that Charlie Chaplin movie, and then you take notes about art.
Okay. Didn't really
I
know.
love when people think we look up all the time.
I know.
But it's not a fun movie. It's
I
about.
liked it.
It's about. Well, I mean, it was alright. I
Okay,
guess.
what is he?
Any movie in school.
Cosecant times tangent, and you want to show that it equals secant. Since you're multiplying, rewrite the left side as terms of sines and cosines. What do you get?
Oh, I get it.
Yeah.
Oh, okay, that one was easy. That was easy.
Hey.
Shoot! I understand you. Don't mess it up. Don't switch it up.
Okay?
Now.
Ready?
Yeah.
All right.
Oh, that one was easy though.
Simplify.
One.
I don't know what to do now.
All right, take a look. When you see, now Izzy, one of the things you should notice that you've got a 1 plus something
Yeah.
squared.
Oh, yeah.
Is that one of the identities?
Yeah.
What is it?
It's cosecant squared.
All right, so you get sine times cosecant squared.
Yeah.
What's cosecant?
1 over sine.
Wait, does it equal cosecant? No? Okay. Not close.
You're on the right track because now,
So you get 1 over sine.
Oh, I was right. Because I did it kind of weird.
you can go the other way too if you wanted to rewrite sine as 1 over cosecant. If you have to,
Okay.
that's fine. That's perfectly fine. Nothing wrong with that. Okay? Nothing wrong with that.
I like it.
So far.
No, I got a lot. We do a lot of this. We just did this one, right?
We're all out of things.
Yeah, we are running a little short here.
Is this verify?
I'll start passing these out. You try that one. Yeah, it's a verify.
Nice. Okay, 1 minus tan
Also,
squared
the
and
pedestrian one. The one where pretty much all you learn is don't run over people, don't run over bike. Like, what am I gonna do?
I hardly just.
Like, obviously, I'm not supposed to
What's this 2 nonsense?
Yeah.
What do you mean, what's this 2 nonsense?
I know.
Oh, wait, I didn't get that.
You guys ready to get really, really upset?
No, wait up.
Yeah.
Don't do it.
Oh, don't do it.
No!
Is it 2, 1 plus 1?
Yeah.
Heck, no.
I was about to do some like.
What's
weird-
1 minus secant squared?
1 over cosine.
Cosecant
Tangent
squared.
So then you get 1 plus cotangent squared?
What? No.
Oh,
Oh, sorry. Secant squared is what?
Ask for that.
1 minus secant squared is tangent squared.
no, secant squared minus 1 is tan.
Oh. Then what are you going to do?
No solution.
It is not no solution. Here, since we're running a little short here, what I want you guys to do is work through the first. It's the second section, this bottom part where it says written, the written exercise is this bottom part. I want you to try a couple of the verifies. The first 18, I'm not going to lie to you, you should fly through. A lot of them are the same problem. Okay.
Like, can we put the
Oh.
answer?
What's that?
Where's the answer to this?
Where's the answer to that?
What is it?
Oh, we have. Oh, let's finish this. We'll start with this one tomorrow.
Oh, don't forget.
Try it.
This number is 10 and 11, those all cross out.
What's that?
Like 10 and 11.
Oh no, that's what I'm saying. I don't know if you saw me when I was holding this up. Start with this 1 through 18 on the bottom.
Oh, okay. Wow. Okay.
Okay. Yeah, some of the other ones in there.
I can read a book.
Oh,
This one.
I was testing you, man. Yeah.
I have to go to help, I gotta make it snappy.
Oh, good fun. These take a while to get used to.